Welcome back, everyone, to another lecture on statistics, but we want to talk about standard deviation and variance calculation in this lecture specifically. So the topic is standard deviation calculation. It's an important topic. I'm going to go over this example from A to Z, one by one. I'm going to explain everything. And any other question of this type you are doing as part of your homework exercises, then you always follow this model, okay? I'm assuming that you have already watched the previous lectures on statistics unit several times, and you have mastered all those topics, and you understand when we talk about mean or average, you know what we're talking about, how it's calculated, and you have some sort of initial background. Okay, so the problem says packages of raisins are chosen randomly from a production line to check their contents. So there's a huge factory, they're producing packages of raisins, for example. It's a huge factory, they have like all this machinery and all of that. And we are randomly choosing packages of raisins, okay, from this huge production line. Each package should contain 60 grams. On the label, on the package, it says 60 grams. That's the weight. So it should contain 60 grams. But in reality, sometimes it is more and sometimes it is less than 60 grams, believe it or not. Of course, most of the time it could also be 60 grams. So sample masses that are taken, when we check all these numbers, we see that one package had a weight of 61 grams. The other one was 59 grams. So the first one is 1 gram more, the second one is 1 gram less. And then we have 62 grams. So this package had just a little bit of more raisins. The mass was 62 grams. Then we have 60. These are like perfectly, filled in packages. Then we have 58 grams. Then one package was 63 grams, 60, 61, 56, and so on and so forth. So these are a whole bunch of randomly selected packages of raisin. These are the masses in grams, and these are representing our data values, x sub I. So x1, x2, x3, x4, just like that. And that's the first column in our standard table that you will always use. In order to calculate standard deviation and variance, which are different measures of spread of data, we said that there is a formula for the variance. In the past lectures, we said it. And we said that it is the sum of the squares of the deviations of each data value from the mean divided by the number of data values. So in order to calculate this in one shot, it may be difficult. But if you do it step by step, it will be easier. So what we're going to do, we are going to calculate x bar, or the mean, first of all. So mean, or x bar, is sigma x sub I over n. We talked about sigma. We said that is the symbol that shows the sum of the data values. So all these numbers we talked about earlier, you have to add them all up. And that's what we did here. Now, how many values are there in this data set? 1, 2, 3, 4, 11, 12. There's 12 of them. So we're going to divide by 12. N in the denominator represents number of data values. So when you divide by 12, you get 720 in the numerator. That's the total you find using a calculator. And when you divide by 12, you get 60. So 60 what? 60 grams. Okay? So 60 grams is the average or the mean of the mass of this raisin packages. So we found x bar, we have it there. So in the second column of our particular table, we are going to write x bar, or the mean, which was 60. And it doesn't change every time, so it's going to be 60 for every single case. So I'm going to write 60 for every scenario, because the mean doesn't change. Now in the next column, we have the deviation, so-called deviation. So this is the deviation column, and this was the mean column. Okay, deviation means difference between every data value and the mean. So here we have xi minus x bar. So we have 61 minus 60, basically. So that's the first one, 61 minus 60, which is positive 1. Next one is 59 minus 60, which is negative 1. The other one is 62 minus 60, which is positive 2. So as you see, it's not that difficult to find all these deviations. Sometimes the data value is more than the mean, so we end up with a positive deviation. Sometimes the data value, like 59, is less than the mean of 60, so we end up with a negative deviation. So here in this column, we're going to have a whole bunch of positive or negative numbers. So let's do it. 60 minus 60 is 0. 58 minus 60 is negative 2. 63 minus 60 is positive 3. Next one is 0. Next one is positive 1. Then another positive 1. And this one is negative 4 because 56 minus 60. And then negative 1. Okay? So we see that everything is very straightforward. Nothing is difficult. You just calculate the deviations one by one. In the last column of our table, we have the squares of these deviations. We need the squares because we need it to plug in the variance formula. That's why we have to square every single number, positive or negative, it doesn't matter, from the third column, and we write the answers in the fourth column. A negative number squared is going to be always positive. So that means that in the last column, we will never ever have a negative number. So 1 squared is just 1. Negative 1 squared is also 1. 2 squared is 4. Then we have 0, 0. Negative 2 squared is 4 again. 3 times 3 is 9. 0, 1, 1. 4 times 4 is 16. Negative 4 all squared is 16. And we have 1. So all we have to do now is to add all these numbers up. So that's 6. That's going to be 10, 19, 20, 20, 21, 22, 32, and 6 is 38. So total or sum is 38. So in this easy tabular method, we found the sum of the squares of the deviations, basically. That's what we did. So that's 38. Now that we have the numerator, we can write it down, and the denominator is n. So n is the number of data values, which was 12 in this case because we had 12 packages of raisins. So we divide 38 by 12, and we need to use a calculator to see what that would be. 38 divided by 12 is 19 over 6. So if you reduce the fraction, 19 over 6, and that is 3.16. 3.1667. So that's the variance, okay? So you look at the formula, it's just a little bit intimidating. You think it's difficult, but in reality, it's not difficult because you can always construct a table like this, and one by one, you can just do the calculations, and it was not a big deal. I just did a subtraction here, and then I just squared this column to find the last column. And how hard it is to add the last column numbers to find the numerator in the variance formula. So you see, it just needs a little bit of attention and a little bit of practicing and a little bit of review, and you're going to ace it. So we found variance 3.1667. Of course, I put like 4 digits after the decimal point, but I can choose to round correct to 2 decimal places only. So this is roughly 3.17, you can say, if you round it correctly 2 decimal places. Now, standard deviation, or SD in brief, is the square root of the variance by definition. So all I have to do is to take the square root of 38 over 12, or the square root of 3.1667, and whatever answer we get, it will be the answer. So 1.78, I believe, is what we end up with. So the standard deviation of these packages of raisins is 1.78 grams. Okay, so 1.78. Since the standard deviation is 1.78, and that's more than 1.5 grams. So now you may say, why am I comparing this? Because there's a second part in the question. The first part, it just gives us the information, gives us the sample masses. But the second part, it says the standard deviation must be less than 1.5 grams. in order for the production to continue. That's the quality control standard. Maybe the city or the province, has this standard for all the factories that are producing patches of raisins, for example. So there's a standard. It says that the standard deviation must be less than 1.5 grams. Okay, otherwise something somewhere in this factory is not working properly. Something must be adjusted, or there's something wrong in the system. These packages, they have to be perfectly equal to 60 grams in mass. Okay, now if one of them, two of them, or five of them is just 1 gram more or 1 gram less, we understand that. Okay, nothing is perfect in the world. But if you see that there's so many of them that are off the announced 60 gram, amount of mass on the package, then that's not acceptable. Like, what if they sell you packages that there's like 30 grams of raisin inside only, but then on the label it says 60 grams? That doesn't make sense. So that factory cannot continue its production because they're not doing a good job. If on the package it says the package of raisins contains 60 grams of raisins, it has to be 60. Now, 61, 59, just a little bit more, a little bit less, we understand that, but it can't be like 30 all of a sudden, or it can be like 90 grams instead of 60 grams. So that's why there's quality control standards there. And if the standard deviation is less than 1.5 grams, if it is less than 1.5 grams, the production can continue, which means that we are okay with just a couple of grams more or less. But if it's like more than that, we're not okay with that. So will production continue? Do you think the city of Toronto or the Ontario government or whatever authorities are there, do you think they have to shut down this production line? Or do you think they say, okay, you're doing a good job, you can continue? So everything depends on this number, as you see. 1.78, the standard deviation that you and I calculated, is unfortunately greater than 1.5 grams. It's more than that, okay? So the production is actually stopped. Like, we have to stop the production until the situation is corrected. Maybe some machine needs repair. Maybe something in the production line is not working properly, or maybe there's staff issues. Whatever it is, mathematics, the numbers are telling us that there's something wrong in this factory. It has to be fixed. So 1.78 is more than 1.5 grams, and therefore the production must stop. Now, what if we would do the calculations and we know with 1.2, for example, okay, 1.2 would be less than 1.5. So that would be in line with the, let's say, provincial standards. So if the standard deviation was less than 1.5 grams, it's 1.2, let's say, it would be okay for the production to continue. But right now, it has to be stopped, and there's something wrong in the factory, there's something wrong in the production line, it has to be fixed. So you see the value of calculations and the numbers. And of course, everything translates into dollars. Maybe it will cost the owner of the factory or whatever business that is thousands of dollars. Who knows? So the variance calculation that we did, we used this formula, but to make it easier, we did our calculations in the tabulated format. So we found all the squares of the deviations, added them up. That was numerator, and easily we divided by 12 because we had 12 data values, obviously, and we calculated the variance. And we said that standard deviation is actually the square root of the variance. The typical distance of a particular value from the mean is what we call it standard deviation. The greater the standard deviation, the greater the spread of data. Okay? The smaller the standard deviation, then smaller the spread of data. So the typical distance of a particular value from the mean, that's the meaning of standard deviation. Okay? I hope by doing more practice questions by yourself and by perhaps redoing this exercise and watching the lectures multiple times, you can get a hang of these calculations. I think you can do it. It's not impossible. Thank you for your attention and keep practicing.